things to go through today. Most of these I'll sort of flick through fairly quickly because you can read them, you can listen to the other lecture if you want. Thank you. Perfectionist. Yeah, you can read them and go through them yourself, but I'll point out the key parts as we go through. There's something else I want to mention, I can't remember. Okay, so we're looking at, what was the actual title of this one? Linux administration. That is 5A. That's the right one, isn't it? It's Linux administration and user administration, or the other way around? Let me just check. Yep, that's the right one. Okay, so we're going to have a little bit more of a look at the user permissions. Now, the user permissions in Linux are much, much simpler, as I said, than you have under NTFS and some of the other file systems. So they're a good example of what we need to do. Okay, so we're going to have a look at the find files, searching for text patterns, and again, you should have a look at that Bash programming guide that's in the other resources part of Blackboard. And at the very end, there's something on regular expressions, and this is just a better way, or a finer way to actually search on text fields. Again, you will be using this, no doubt, in the final assessment, so make sure that you understand how to use some of these regular expressions, which we do cover a little bit more later. Okay, seen this previously, we have only three sorts of permissions within the Linux file system, they being read, write, and execute. They have a different effect whether you're on a directory or a file, but they are still the same permissions. Now remember that in Linux, as I keep saying, everything is a file, so even a directory is a file. It's just a file that points to other files, right? Like the tree structure. You can read through those. With a file, if you read, you can look at the contents of a file. With a directory, you can see the contents of that directory. So they're a similar sort of thing, but they are slightly different applications on files and directories. So it's listed there. The key, or the groups that are involved are user, which is the owner, group, and others. All right, so you should really set up most of your files with that in mind. I keep mentioning that groups are really important when you're managing a system, whether it be in Mac, Linux, Windows, whatever. Do everything by group. If you do it by group, it makes your life a hell of a lot easier. If you go in and change one thing for one user, for instance, giving them access to a printer, all right, somebody else then wants to use that printer, you've got to go in and do something for that user. If you create a group for that, that printer, you can just add people to that group. When you come to get rid of the account, or the person leaves, or they no longer want access to that resource, you remove them from the group of that resource. You don't have to go hunting down through their account of each resource that they have. Okay, so having groups and arranging everything by groups, either through Active Directory, LDAP, or Linux Unix groups, is the only way really to do your administration, and it's really important that you understand how to do this and how to keep things together. Okay, so we have those three categories of users. Others is basically anyone else. You should normally set any of those resources, files, directories, etc. For others to having no read, write, or execute rights to it, except in some configuration cases, okay, where everyone needs access. Okay, the directory permissions can only be modified by the owners. That's fairly obvious. And the super user. You should have all used the super user account by now. Root user in this case, or administrator user in Windows, or root user on Mac. Mac users here, anyone? Yeah. Yeah. Okay. Have you enabled the root account on your Mac?
Yes.
You should. It's fun. It's a good way of killing off your machine if you ever want to.
I just use sudo.
Yeah, well, that works too. But having the root account's nice as well because you get different shell, but gives you things to play with. But your way's much safer. Right, and I'll mention this as we go through. All right. So the super user is the root account, the person who has the ability to change anything that they like. You can change this by using the change mod command to change this modifies the file attributes or directory attributes, and there's a couple of different ways of doing it. And we've had a quick look at these before, but we'll just quickly go through a couple of examples. if we do change mod 600 private.text, that sets the permission on the file name, private.text, to be, well, can someone, oh, it's already there, isn't it? Yep, read and write for the owner, and no rights for anyone else. Right, so it's nice and easy to see. You can use the letters as well, but I find this easier, but it's up to you. Okay, to do them symbolically, we can use the symbols U for user, G for group, O for other, A for all read is R, W is write, and X is execute. Right, all straightforward. Put a plus or minus in front of them, and you can add or remove those attributes to the files. Right, so to me, this one here, where we're using the symbolic method, makes less sense than using the numbers. Right, but it might make more sense to you, so really up to you. We have the ability to do things recursively. This is very common using a -R, in this case capital R. Be very careful you're doing anything recursively, because that will then affect everything from the level you're at all the way down. Okay, so if you change the ability to, say, write files recursively, you're giving write permissions all the way through the tree, and that may not be what you intended. So quite often it's better not to do that, but go through and do things individually, or better yet, write a script to change permissions for the user according to their groups. Okay, so if you're going through and you're looking at putting in a new application which requires users to have different file permissions within that application directory, write a script that will do it to add users to the group that has those rights. Okay, we can change groups in much the same way, just chgrp, and you change the group ownership of files. Very straightforward. And again, setting group ownership of files is also a nice way of doing things. We've had a look at reading file contents. The normal one is cat, that's a nice easy one. Remember what it says, it's concatenate, joins the content of the file to the screen, right, because everything is a file, you're just joining them together. If you cat one file name and pipe it to another file name, you join two files together. All right, so it's all the same concept, which is what makes Linux so easy, or Unix so easy. We have the ability to look at a file from a high level by using the files command, and it will tell you what sort of file it is, sort of maybe if you're lucky. This can be handy for things like doing backups, make sure you're not backing up, say, source files which haven't changed, or files that you don't need. But it actually can't tell the difference between a great number of files. So it doesn't know the difference between a C file, C++, Java. It just comes back and says it's a C file. Because it looks at syntax, tries to identify them, and does it that way. But importantly, it does use the file content to determine what sort of file it is. It's not like Windows, where you have the extension which normally sets the file type. So if you've got the .exe, it means it's an executable binary file. Linux Unix doesn't do that at all. Does anyone know how Mac handles that for its file extensions or file types? Yes, Sindel.
I think it's .gmg, so
Sorry?
I think it's pretty sure it's .gmg. So,
Well, there's a dot file for every other file, and that contains metadata of the file.
yeah.
So if you get a USB that's been plugged into a Mac, you'll see it's got all the normal file names, and then it's got dot and the file name. And that dot file is actually the metadata describing what the actual file does. Sometimes it's just empty, sometimes it's got something in it. So that's not really a good way of doing things, but there you go. Okay. Other ways of examining files. When you're looking for things like logs in log files, head and tail are very useful, and they are pretty obvious in what they do. Head looks at the top X number of lines of a file. Tail looks at the bottom X number of lines in a file. Now, this is really, really handy if you are looking at a log file that's being continually updated and you want to get a feed of any new entries. You can just be running tail and get each of the new entries that come out at the bottom of it to continually scroll out to your screen or go into another process. So if you're looking for bad logins, maybe little security things, see if someone's trying to break into the network with the guessing passwords, you can have your failed login log file piping out using tail just the last entries to see if you start getting repeated failed logins. All right, so a couple of examples there. Tail -20 messages.txt will give you the last 20 lines in that. and we can have tail-F, which will give us that continuous streaming of the last entry in the log file. Normally what you would do, for example, is you'd stream the tail-F and whatever options out to another script, which would then sort through looking for whatever attribute you're looking for, and when that event occurs, you'll get a notification that something has happened. So a very handy thing to be able to use. Okay, we can also have a look at files which don't normally appear on the screen very well, such as the binary files. So if you've got an executable and you try and cap that to the screen, it'll lock up your screen, put it into some funny mode that you can't get out of quite often. But if you do want to look at what the content is, and this can be useful to check certain things, we can use object dump or OD, which is octal output. And this will actually throw or show the binary contents of the file. An example we've got there is a text file, contains hello world. If we do a OD, right, using characters, it will actually give us each of the characters separately in a string that we can then pull each character out and use that in the script that we're after, so if we're looking for particular values. If we do it in X, it will give us with the X option, it will give us in hexadecimal, which I hope you can all count in because it's a wonderful numbering system. And it will give, for instance, the hex for H is 68. Right, it will give us the hex numbers there. Okay, I mentioned this one before, and finding files. Finding files is, well, not as easy as under most other systems, particularly from the command line. Now, remember, when you have a server installed, generally you will not have the GUI installed on a server. It just takes up space, uses resources, and as I will mention a bit later on, creates a great number of security possible exploits, particularly if you're using Windows XDM type systems. It allows people to break in quite easily and get around things like password files. So your server quite often won't have the graphical search capabilities that you have in most file managers. So you'll need to go looking for files manually. Additionally, when you're running scripts to automate systems on your servers, you will do this using command line stuff, which means you need to know how to find files yourself. Okay, so find is probably the most common one to use. Just searches for the string that you input, usually by name, but you have other options in there too. But remember, if you're doing find and you're at a high-level directory, it will try and look in all subdirectories as well for the pattern you're looking for, which means you may not have permissions to go into those files, or they may not be readable for some other reason. So you're going to get a massive string of errors out from it. Therefore, it's fairly important that if you're doing this, that you use that little trick we mentioned before, where you have your output, number 2 here, which is, what's number 2? Put standard input, standard output, and standard, come on, talk to me, somebody please. Standard error, right? The file that you put any errors out to. Standard error normally goes straight out to the screen, same as your standard out. Standard in is your keyboard, remember? All right, so we use the standard errors out to the dev null, which is a non-existent place. All right, so that will mean that you're not getting all of the error messages. A very common thing to do and something to make great use of, because those error messages can wipe out what you're actually looking for. So get rid of the error messages, in this case permissions, where you don't have permission to actually look inside the directory, and you put them out to dev null. Okay, so that's what that one does. Using find, you can find files by type, F for file, D's for directory. We can look at permissions and size. Now, again, when you're creating your scripts, you might want to go through and clean up all of the 0-byte files. They're just an entry, they use up inodes. They're not harmful in any way, really, but they can clutter a system. So what you want to do is go through and you search for all files of a given size, right, of 0. Right? So we actually go through and find them, and then we'll delete them. Or you might want to go through looking for large files to clean up space. So size is a useful thing to look for. Permissions is also another one. It can be handy looking for all executable files within your system, so you can exclude them from a backup. And there's quite another number of others. Okay, we can execute commands on those return files. So here, if we want to go through and we want to see how many words are in all of the documents that are within our document directory, we can pipe that through to WC, which is word count, and actually have it give us a word count of every document that's within our directory, if that was any use to anyone, which it quite often wouldn't be. But again, as I said, it's making use of that output and putting it into some other routine. All right, so find is probably the most useful, which is also a handy one, particularly if you're concerned that your system may have been compromised. One of the old ways and fairly traditional ways of breaking into a Linux system is to replace common commands which reside in the bin files or the sbin directories, and you replace them with some malware. Right? It's a nice easy way to break in. ls was a really common one to replace, so when you typed in ls, if you were in the right directory for this, it would execute a local ls to list all of the files in the directory, which had other malware in it, which would then go through and hijack your FTP server or something similar. That was a common one anyway, hijacking the FTP server. By using which, you can actually check to see which version of the command you're using. So it will return the location of the command that you're using. So in this case, when you type which ls, it will return bin/ls, so it's using the right one. If it's say return ftp/bin/ls, that's a good sign that you've been hacked. FTP servers are a wonderful open system that should never be installed. Okay, and we also have locate. Locate is can be slow, and helps at finding particular files. So there's a few examples there. I thought I did this before. Anyway, locate works on a database. It's only updated once a day, so if something changes, locate might not find it if it's been recently created, and it might not find the right one if it's changing quite often. Okay, we had a very quick look at grep. Grep is a way of, when you're looking for things, it helps you find them because you can filter with it. And this is where the regular expressions come in. So we can start matching particular fields, particular parts of the return values from, say, just listing the contents of a file, and pulling those parts out and changing them or using them as a input to the next process that we want to run. This is how you build your scripts and put them together. So, simple way, if we look, did grep, we did this with cat and dog or Linux and DOS, whichever example I used. Just grep hello in the file star.txt. So it'll look for hello in any file that ends in .txt. Very simple sort of search. We can also count the number of lines of match. We can ignore case. Now remember, Linux upper lowercase are very different, so that's handy. You can change it so it prints the lines that don't match. Okay, and again, that can be handy under certain circumstances. Alright, so that's again one thing you're going to have to play a fair bit with. Once you've got the contents of a file, you may want to sort it, perhaps into date order, size order, date and modified order, all kinds of things. And we have the sort routines which will handle this for us using the alphabetical size, etc. You can have a shot at those. They are in the those bash scripts to use them. So, yeah, best way to do these is go through those assignment documents and have a shot at the sort and unique parts. Okay, so when we're doing our backup, and this is going to be a part of the assignment that you're doing, you'll have to have some backup regime, whether you're using Linux system for backup or whether you're using some proprietary system. You'll need to decide, but you'll have to justify why you're choosing that particular system. Linux backup is really fairly straightforward. Sounds rather old-fashioned. For backups and not compression, but joining of files together, we use tar. Tar is tape archive. Has anyone here played with tapes on computers? Yeah, fairly good, aren't they? Really slow, but they store lots. That's the secret. I actually don't know how big they're getting at the moment, but the ones I'm using out at Guide Dogs, 16 terabytes, something like that. But they're big, right? But the problem with tape is it's sequential. Right? So if you're looking for a particular file back off a tape, you've got to start at the beginning of the tape and read through kilometres and kilometres of tape. so it can take a significant amount of time. But tape is very, very cheap. All right, and you can also have tape cartridges. So you don't just have your single 4, 8 terabyte tape. The machines I've got out at Guide Dogs, as I said, I've got 2 of them, and they handle 13 tapes each. So you have a bank of 13 tapes, and the machine will automatically change them and rotate them through to do your backups. So it gives you this massive amount of storage that can be fully automated to run your backups. Problem is, and I'll keep mentioning this later, well, I do mention this a bit later on, if you're doing your backups in your server room, which makes sense because then you're not transferring all this backup data over networks, and when you're talking about tens or hundreds of terabytes of data, sending that over any network is slow and time consuming. So you really don't want to be sending it over networks. So you'll run your tape libraries within the server room next to the server, connected together using something like Fibre Channel. Fibre Channel we can talk about in one of the other units, but very high speed data transfer, much better than Ethernet, much quicker. But that also means that your tapes are sitting in the same room as your servers that you're trying to back up. If anything goes wrong, you're going to lose your tapes. So the purpose of the tapes was to make sure you've got something apart from the servers themselves. So you've got to have a method of getting those tapes out of there on a very regular rotation. Fire in a server room means your servers go, means your tapes go, means you're finished. All right, so you should never store your tapes in the same place as your servers. You should not even store them in the same building as your servers are. I used to work for, in the good old days, a data processing company, had a room something about the size of this lab, full of mainframe computers, which we would then back up, and we'd take the big spools of tapes like you see in the movies. Silly things in movies, they go backwards, forwards. It doesn't do anything. You write it from the beginning to the end, so they just ran one way. Anyway, we take these big spools of 2,400 foot long tapes, and we carry them off to the building next door for storage, which was nice and safe, except it was a totally wooden building in West Perth, and about 100 years old. So you couldn't smoke in the building, you couldn't have any sparks, and the whole thing would go up. And we were storing all of the tapes belonging to some of the biggest banks and building societies in the state in this wooden building. Not very clever. But it was cheap and it was right next door, so there we go. Okay, so tape archiver, still very useful. Even if you don't have a tape, it's a great way of doing your backups. What it does is it takes all of the files that you feed into the tar routine and just sticks them together and creates one file with a string of just all the files joined together in a block. It doesn't do any compression unless you tell it to. All right, so generally we make this tar, which creates a single file, which we can then search through and put onto some other media if we want. But generally we would actually compress that using zip, the open format zip, or one of the file compressions. Just so that Sindel gets this joke, there's a picture there of a Toyota with a number plate of tar space XVF, which is exactly what we want to type in if we want to extract a tape archive from a tar file. Yeah. Okay, so tar creates these continuous files, a continuous file of all the files that you feed into it, and you can then pull them back out using the options. To create one, CVF is the normal options you would use. Create, verbose, and do a file. You can set that somewhere else. Verbose is handy because you actually want to pipe that output from the tar command to some other file, so you've got an index of all the files that are backed up. Now, one thing I will mention probably a few times is once you've created this tar file, you zip it up and you put it onto a tape or some other media to store it. Is that your backup finished? Yes, no, maybe. Come on, 3 choices. Someone make a choice. You are quiet. No, it's not. Because if you do your backup and then you put it onto tape, and if something has gone wrong, how do you know? And there's a very good example of this. One technical staff member at Curtin, who is now an academic staff member, and it wasn't me, decided that they would back up all of the computing department's servers, wipe them, rebuild them for the next semester, and then restore everything. Which he did. He went and did his normal backup that they'd been doing for years and years and years. He wiped all the servers, he got his tapes back, went to restore it, all the tapes were blank. right? And that was it. And they've been blank for months and years, long, long time. So once you've done your backup, go through and restore it somewhere every now and again to ensure that you are backing up what you think you're backing up and it has worked. Absolutely critical. No point going through a backup and not being able to pull things back off it. And also make sure that your backup methodology is available to other methods in case the method you're using becomes outdated. Alright, so do your backup, check your backup, store it somewhere else. There are other utilities for doing file compression and backup. CPIO is one, but don't worry too much about that, it's just there. And there's other options for it. Alright, so we won't worry about CPIO. And then to take this file, which remember is uncompressed when it comes out of tar, you pipe it through another utility. gzip's a common one, and that's the same as your normal zip algorithm that you find on most systems. It just happens to be the GNU zip, so it's open source, and again, it's nice because it means you can uncompress it later, even if the application that you were using is no longer available. This is another reason to avoid specialist unique type hardware. If it becomes superseded, the company goes broke, you've got no way of getting your information back. If you have any information on one of the old zip disks, which you guys probably can't remember, a hard plastic, sort of like a CD-ROM inside a plastic case, we thought they were wonderful because they would store 100 meg. Woohoo, big. Yeah, big floppy. Yeah, floppies were 1.44 meg. Well, they did a 2.88 for a while, but never caught on. So 100 meg was great. You can't find a zip drive anywhere anymore. So if you had your last will and testament, or worse, your rich uncle's last will and testament on this zip drive, and that would get you millions of dollars in inheritance, you would have no way of getting that data back. So when you're working out what media to put things on, it usually pays to make sure it's something that is, number one, open source, so you can get it back again if the vendor of the equipment or software goes broke. And it is on some form of media which is very, very common, and you know that you can get it back for a fairly long period of time. It becomes very expensive, say, to get things back off these 2400-foot tapes that we were using in the 80s and 90s. There are places that still have the tape units to read them, but you pay an arm and a leg to get it done. When things become out of date, so we move away from a particular type of tape unit, then make sure that you take your backups and you move them onto something more up to date. So you're going to have to back up your backups, which gets big. Why don't we all just put this on these large terabyte drives that we have nowadays? Because in corporate situations, data is huge and it's getting bigger and bigger. We look at big data nowadays, and we've got terabytes of data coming down every day from the wide field array in the Murchison with the radio telescopes. You can't back that up. There's just nowhere to put it. You get a few petabytes in a week, and where are you going to put it? It's just too big to store. All right, so we are having problems with storage, and things are going to change to try and keep copies, or we compress it and get rid of it. All right, now, when you're starting to look at removable media like tapes, Linux is not very friendly in the way it does things, but it's simple to understand, but it's not automated. So quite often when we have particularly legacy equipment that we need to recover something from, we have to do manual mounts and unmounts of the systems. And unlike Windows and Mac, where you plug something in, it automatically finds it, loads it up, there it is, a server-based system under Linux and Unix will probably not do that. Why not? Come on, somebody talk. Security. Here is your server. I walk in with a thumb drive, I plug it in, it automatically mounts. I could have a script on there like the autoplay under Windows that then starts pulling data off. Okay? So you need to be able to limit who can mount things. We look again at the guy in the US military, took a CD in, Snowden wasn't his name, took a CD in, plugged it in, everyone thought he was listening to music, but he wasn't, he was copying sensitive data off the military's machines. Right? If you can't mount that, which is what you would do under a server-based system, remove the ability to auto-mount stuff, you would have to have root access rights to then go and mount the drive so that you can start copying things off. So what you do is you take away all of that ease of use and ease of mounting and stuff a user would want from your server, and you make it more difficult and more controllable for people to access information. So we take away the ability for a non-root user to mount removable media or USB drives or external drives, whatever. That means we then have to be able to do it ourselves, and we use the mount command. Now, previously I mentioned how this mounting works in Unix and Linux. We create a directory called /mnt normally. That's what we would, just the naming convention. And it's just a directory. Within that directory, we create names for each of the removable medias that we want to have attached to the system. So if we were trying to recover our rich uncle's will from the zip drive, we would create /mnt/zip drive. That just creates a holder to connect the user to that file system. You then have to mount that file system and connect it to the /mnt/zip drive folder. And you do that by this mount command. Okay, you can have a look in the etc/fs tab. That's a file system table. All of these are quite readable, these names, when you work out sort of what they're meaning in the naming conventions. So fs is always file system, tab is a table, so fs tab is your file system table. If you put things into the etc/fs tab file, they will be there all the time. Okay, so here's an example that would be in the fs tab, but you can also mount things separately. So in this case, we have an entry /dev/fd0. /dev is a directory that holds the pointers to the physical device that you are trying to mount up via the driver, of course. All right, so on your virtual machines, have a look inside the dev directory and you'll see a massive list of wonderful devices, which is everything that can be attached to your system. In this case, it's fd0, floppy disk drives, wonderful things. Well, I went through lots of iterations of these. The very first floppy disks were a 8-inch square thing, and they held 64K. And they were big. They had super millions on that. Anyway, so there we create our mount point, /mnt. Within mnt, we create something called floppy or whatever we want to call it. And we can auto mount it. So we will look at the file system and decide how to mount that particular file system. That is not always the case, particularly with some of the legacy systems. So, in the case, oh sorry, go through the rest. We're setting up, so it's read, write, and set up for read, write for all users. So because it's a floppy disk, we can read and write to it. We can set it up as read only if we like, which is what we do for the next one. So the next entry is /dev/htc, right, and that is just a standard location for a hard drive type device. We're mounting it in /mnt CD-ROM. And because CD-ROMs came in a variety of flavours, we had to give it the file systems that we're using. In this case, it's ISO 9660, and that was a particular style for CD-ROMs, 680 megabytes of data on them. Because it's a CD-ROM, we all know what ROM stands for, read-only memory, so we can't write anything to it. We set it so that we don't get errors to read-only, the RO here, right, and that's all using no auto mount. All right, so we can do that in the FS tab if we wanted these devices to be there whenever we start the machine. But if you're locking it down and you don't want people to get to these utilities or these other things, we can also do it directly from the command line. So here we have the mount where we're mounting it to. Remember, this file system has to be created, it has to be there already. If it's not there, you'll get an error. We then change into the that directory, and if we have a look, we've got all the floppy stuff there. Right? So it can be as simple as that. Then when you're finished, don't forget to unmount it or you can't unplug the device. USB's example on the next one, because we can have different types of USB. Again, we just make the directory we want. This has got a little bit more detail. We've got the mount, and we're using VFAT, which is the FAT32, virtual FAT file system. For the owners, read, write, and where it connects to in the dev tree. So where the device drivers are and the files on how to access it. If you just type in mount, you can get a list of everything that's there. So in your virtual machine, have a look for the FS tab file. It should load up a few things like HDA1, HDA0, etc. It should also have probably won't have a USB, but have a look what's there anyway in your virtual machine. Okay, so a bit on redirection. Oops, Redirection we covered before. Also on processes and redirection. As I said previously, one of the strengths of Linux and Unix is you can redirect the output as the input to the next process, and everything is a process as well, and we control those processes individually. So process is simply any program that you're running. Right? So you can get to that, as we saw, by using the PS commands, but we've got other ways of doing things as well. We have the initial process which is running. Normally, when you start a machine up, you will get the process manager itself under Linux, which will become the first process, and every process after that becomes a child of that one process. Processes are kept in their own space. If you've done operating systems, you should cover lots of stuff on this. So they are not quite sandboxed, but they are kept separate. Users get their own memory, they get their own time allocation, etc. All of our Unix processes are identified by the PID, process identification. These PIDs are kind of important and will be really, really crucial when you're maintaining a system, because you will want to know what the PID for a particular process is. You'll want to see if it's using memory or CPU. Sometimes you want to use CPU because that means it's working. Sometimes it will become runaway and use all of your CPU, and lots of programs have memory leaks, so they'll just be sitting there doing nothing but increasing the memory usage over time until they use up all the available memory and the system crashes. Well, it shouldn't crash nowadays, but they can. And that's very common in things like web browsers. Firefox is notorious for having memory leaks, and it just starts using more and more memory, so you shut it down every now and again, clean everything up, and all becomes good. But because you're running a server in this case, you've got lots of processes in the background doing things like serving web pages or FTP or your printers or file management, user authentication, lots of things. You want to be able to watch those and see if they become zombie or they start using extra resources, or in fact, are they running at all? So if a particular key process like your web server is running on the server in the background and it crashes, how do you know? You wait for your customers to call up and say your web server's down. In a lot of cases, they won't bother, they'll just go somewhere else. So you really want to know. So you keep an eye on the process ID that is associated with your web server, and every now and again you go and just check it, and every now and again can be every 10th of a second if you want. And if it's not running, you restart it. And you can do this in a variety of ways. But you do want to have some way of checking on these processes. Here we go. Init is the first process that starts, and that's at boot, and that gets the PID of 1. We've got some examples coming up as well. Okay, so just a reminder, we have pipes and redirection. Pipes are things that Bogans and Rotten had. Pipes are things that take the output of one process and pipe it into the next process. And that's just done with a vertical bar. The example we've got here is we cat a text file, we pass that through to sort, that puts it into the order that we want, alphabetical order in this case, and then we pipe it through the unique process, which pulls out all of the unique lines. Right, so piping is very handy. Take one process to the next. And there we go. So another example there, just using the dog and cat I mentioned before, because I can't remember we needed that. So if we cat that text file, we grep for dog, so we're actually looking for the word dog, and we grep -v, which means not, basically. Cat, it will return all the lines that contain dog but don't contain the string cat. Okay, so that's easy. Redirection, again, I think we've mentioned this before, but I'll run through it very quickly, is the greater than sign. You can actually use the less than sign as well, but that pipes input into the process that you're using. So instead of a keyboard, you can use a file as the input to another process. Using the greater than, if we do echo hello, we get hello back out on the screen, but if we go echo hello greater than output, it will take the response of that echo and put it into a file called output. All good. Anyway, so this is really handy. We're running a process in the background, which we'll look at in a sec. But we want to see what the results of that are. If it's running in the background, we get nothing displayed on the screen. So what we do is we pipe it out to our log file, and we keep a record of what the response from that process we were running was. Okay. So if we then have a look at the contents of that output file, it'll just have the result of that execution. Okay, but there's a problem. what happens when the bash environment sees that greater than sign, it immediately goes off and creates a file of that name. So in that case, echo hello greater than output. As soon as it sees that greater than, it creates a file output. If we already had a file called output, it would be overwritten, gone, finished, and an empty file called output would be created. If we want to append things to it, it's really difficult. We just use a double greater than. And that means it goes and checks to see if there is a file. If there isn't a file, it'll create it. If there is a file, it goes to the end of that file and starts writing the output from there on. Right, so we can do that. And as I said, we mentioned this before, standard error. We can output that to dev null, or we can keep it somewhere else if we want. And that's a very handy thing. So, yeah, they're all there. Okay. Okay, we can redirect things to two files if we want. So in this case, we've got to find everything in the current directory. We want to print it out. We put the normal response, the standard out, which would normally come to our screen, goes into something called files. So I've got one greater than files, followed by two greater than errors, and that means all of the errors, like you don't have permission to read this directory, those messages would go into the errors, and your real output would go into the files file. Right, so again, find everything in this directory, print it out, pipe the standard output, 1, greater than, into the file files, and standard errors, number 2, is redirected into an errors file. And that way you would actually get nothing on the screen, it would just create those files. Okay, and then we've got some other examples of how to do it. Okay, we can combine the redirection of the input with output, which makes things really interesting. But you've got to be careful that you don't use the same file name in both places because of that problem where the greater than sign immediately creates the file, therefore you lose your input file. And you can read through those ones and have a look. Okay, this is a small example. So looking at processes now. Processes are fun because you can go off and kill things. And killing things is always great. Go hunting. I'm going process hunting. Okay, most of the shelves have a reasonably sophisticated job control facility routines within them. Again, harping back to the good old days, and we are moving back towards this again, we used to have batch mode processors. So when you had a job to run on one of the really big machines, which was about as powerful as an Apple Watch nowadays, you would go to the operators behind a glass window and nice white lab coats, and you hand over your pack of punch cards to get your program to run, come back a week later and they would give you a printout with the results of this program, which would usually come back to say syntax error. So then you have to go and repunch all the cards again. Oh, it was terrible. It was terrible. Very time consuming. And then you drop the cards. You'd write a program with 5,000 cards and trip over. Not nicely. And it was the only record you had of them, by the way. Anyway, we're heading back towards that where we have very large jobs that need to be processed and you do them one at a time. Right? That way you get the full use of a very big, powerful machine for a limited amount of time. You run that one job, it spits out the result, and there you go. Examples of this currently would be things like payroll for large organisations. At Curtin we have, I think about 5,500 people employed. That's headcount, not full-time equivalents. 500 of those people actually work. It's interesting, isn't it? No, I don't. I'm going to cut this out of recording. Okay, we've got 5,500 people. They all work different hours. A lot of people, a very large number of people, are paid only on the hours they work. And sometimes they're not even paid then. Are they, Jonas? Trouble with payroll. Okay, so we don't know how many hours all of these people have worked up until the day before we have to issue the pays, which means we've got this massive job of calculating all the pays, the tax, the superannuation, the leave balances, and all the rest of the stuff for this very large number of staff, and it has to be done and finished by 8 AM the next day to get the information to the bank so people can be paid. Which means if you try and run it on a shared system, you don't know when it's going to finish, you don't get the full power of the environment, and it's a big job. It just has to be done quickly. So we have a machine that only does one thing at a time, and these are the batch mode machines. We still have that ability to say, right, we want to run jobs in a batch in the background, let them run. Simulation is a good example of this as well. Let them run, and when they finish, we'll get the result back. So Linux machines are very good for running these batch jobs. Right? We can run them in the background, and we have job management for it. So jobs, these are just processes, programs, they're producing something, a simulation, a payroll, whatever, can run either in the foreground or the background. 99% of the stuff you've been doing so far, you will be running in the foreground. Right? It has a screen that comes up in front of you, there's solitaire, we're playing solitaire, that's your process, it's running in the foreground. What you will also have is things running in the background which you don't generally notice. And with Linux, we have the ability to control whether things run in the foreground or the background, and it doesn't matter what sort of process they are. Okay, it can be a game of solitaire, and it can run in the background. You can't interact with it, but it can still run in the background. We can also schedule them so they run at particular times through these job management things, and also a little routine called cron, which I'll show you in a sec. You can suspend and run foreground programs, so if you want to stop something, it's eating too much CPU, you've got a large simulation running, you want to suspend it, move off, do something else and come back and restart it, you can do that. If you want to create a process to run in the background, you just stick an ampersand on the end of the command line. So if you do ls space ampersand, it'll run a list of the files on your current directory in the background. Where does the output of that go? Not a hard question. It's a hard answer. Nowhere. Because it's a background process, it doesn't have a standard input and output. Right, so it just gives you nothing. You'll get a process ID, and then you'll get something saying it's complete. That's it. All right, so if you run things in the background, you've got to make sure that they don't require human interaction, which is why you script them. So you would have all of the input. For instance, running your backup for your environment, you could run it in the background, but you would have it fully scripted and outputting the standard out, standard error off the files, which you would then have tail just giving you an update of everything that it's up to so you know it's still running and what point it's at. Right? Again, script. All right, so adding ampersand to the end of a command will make it run in the background. And here's a really simple one. We're just doing a find of everything in its current directory. We want to print it, and we're going to put the output into the file output through a redirect and send standard errors out to the file called errors, and we've got that magic little ampersand on the end. So what will then happen is we will just get number 1 in square brackets, which is our job number, so we can go off and identify that job, see if it's running, etc., and the process ID for it. Right, in this case it's 27501. Okay, and that's the PID. If we type in jobs while this is still running, we will get a report back of what jobs are running in the background. Okay, and not much else. All right, yep, and you can bring them up one by one by using the N option. To identify processes, we can just use the PS, which we had a look at before. Always fun to do this because if you run it and you find out what your process IDs are, you can then control each of these processes. The process that's running, PS, will also appear within this list, so it'll give the one that's actually giving you the information. But a fun thing to do, if you open a bash shell, find out what PID the bash shell is running under, in this case 17717, and do a kill -9 17717, you kill your own shell, and it just comes back process terminated, and that's it, you can't do anything else. Because you're clever, you're running the system, it won't warn you. And again, you can do a kill asterisk and see what happens there. It's always good fun. This is why we have backups of your virtual machine. Keep a copy somewhere else, because it's good fun actually to find out what breaks and see how it can break. So try a kill asterisk from the top level directory, it's not top level, from the super user or root account, and see what happens. All right, so we have the kill. There's lots of different ways of killing. The kill -9 is a signal. It's actually the SIG term, which is just a terminate uncleanly. Kills it abruptly, just drops out, disappears, doesn't shut anything down. So any files you have open may be corrupted. It doesn't actually close anything down. It doesn't necessarily free up memory either. So you may end up with memory left there. So it's not a nice way to do things, but it's quick and dirty and easy. and most people will still use it. But there are a range of other signals. If you run kill -L, it'll give you a list of different signals. So there's others that shut it down cleanly, there's others that just pause it. But, yeah, have a look. The kill -9 is a normal one. Okay, you can have a look at all processes running using the different options and that change between different flavors of Unix and Linux. You've got to work out which one you're using. FAE on BSD type systems and AUX on Linux type systems. Better way of having a look if you're just monitoring things, use top. Top will give you a list of all processes, so if you want to have a run of that. And that will give you the processes that you're looking for, see who's using the CPU, see who's using memory, much like Activity Monitor on Macs or the other thing on Windows. Okay. Normally you can only kill the processes that belong to you, but if you're root, you can do anything. Like you might have seen some of the computer science geeks wandering around with that t-shirt saying, "I am root, bow down before me." Yeah. Okay, some other useful commands that we need in our admin, rlogin and rshell. These are remote utilities to be able to, say, get access to that machine over there. I can do it from here by doing a remote login or remote shell. If you are a system administrator and you still have these running on your system, you should be shot. They don't require passwords. They are very, very insecure. So these services shouldn't be done. You should use either SSH or the secure shell stuff. But SSH is the better way of doing it. Much the same way as Telnet. Have you all used Telnet?
Once or twice.
Well, it's still handy at times. Telnet is a way of connecting to a machine via Ethernet as a normal login, so you get your normal command line login. There's other ways of doing it for the windowed environment, not Windows. But it's an encrypted, SSH is encrypted, Telnet is not encrypted. Generally sends only one character at a time, so you hit the L key, it sends the L in a complete Ethernet packet, right, which is an IP packet, which is a TCP segment, which is really big for holding one character. Right, so very inefficient as well. But Telnet is very insecure, you should use SSH wherever you can. Another problem which we'll talk about a bit later is X11. X11 is the windowing system that is used within Unix and Linux and is inherently insecure. Okay, some other useful commands, SCP, which is source copy, and another one that I particularly like is links, and that I tried to run that before, it wouldn't work, and I found out what the problem was. But links is a text-based browser. As I said, asked why would you want to use a text-based browser? Because your Linux server, Unix server is command line only, you don't have the graphics. You want to sit there on your machine, nip off to see a manual file or a help file on a particular problem that you've got. You don't have a web browser, you've got to pull out another machine, or you can just use this, which is a nice little browser. Sindel, you probably like it because it's really, really simple. And it runs on Mac too, so. Yeah. Okay, so that's that one. And that's also very good for stripping out text. So if you've got a script where you want to find a particular bit of information on the website, you can use the regular expressions and grep and sed and awk to pull out bits from a website because it's all text-based. Much, much easier than you would with a full browser. All right, so there's printer utilities that are listed here. Have a look at them. I think somewhere in the labs you will be doing that, setting up some printers. If not, don't worry about it. It's fairly straightforward. Again, it's just pointing at the right things and having a queue in the var directory to do it. Okay, I think I've covered enough on the super user and root user to cover it. There's just a couple of little things that you should be aware of. Number one, okay, never log in as root unless you absolutely have to, and only ever do it at the console of the machine that you're working on. But don't do it if you can avoid it. Never remotely log in as root because that means your password is going over the network and that shouldn't be allowed. Nor should root access be allowed remotely anyway, no matter how big your password is or how secure your connection is. Because remember, root can do anything, right? Anything at all. So you don't want anyone to have access to it if you can avoid it. Right, never use root account for mundane tasks. There's an example here. If I typed in rf star space dot text, sorry, rm minus rf star and a space dot text, instead of rm minus rf star dot text, Do we know what that would do?
Delete all files.
Correct. Because it looks at the white space here, a simple misplacement of the space, and it says all the system says RM is RM minus RF star, which means remove all files recursively that match anything. And that dot text has no meaning at all. So that is completely different to RM minus RF star dot text. It will delete everything on the system. And because you're a root and because you know what you're doing, there is no are you sure, are you really, really sure, are you sure you want to go ahead with this type stuff? It'll just go and do it. And the next thing you know, you'll be typing at the console and nothing's happening because everything's being deleted. It consumes itself. It's good fun to do. When you finish this unit, get your virtual machine, go to super user, go to top level directory, do RM minus RF star and see how long it takes before it dies. Not long. Okay. Super user, the SU command, a little bit different to sudo. The SU is actually switch user, not super user. Okay, and it allows you to become any user on the system. So if you need to get into someone's account, really bad way of doing things, and you have their password, you can SU that username, enter their password, and you become that user. Not a common thing to do because you don't want to have other users' passwords, but you might have multiple users for different purposes of your own. If you do an SU minus, it gives you that user's startup scripts, right? So you will get that user's environment. For example, when you just SU going to super user or to root, and you don't use the minus, you don't get the sbin directory, so you don't get access to the system administrator utilities and the files that are in the sbin directories. If you do SU minus, it runs a login scripts, a .profile or .bash profile or whichever shell you're using. It runs that and you get that user environment as well. So SU minus is a handy thing to do. Probably a good alias to set up in your login is whenever you type SU, it actually does SU minus. Right, so you get it automatically. Okay, and that's for access to these sort of things. The user add script which adds new user information, etc. So, I did want to say something about it. I think I'll talk a bit further about the user add, but I'll mention it here anyway, just in case this is the bit I was going to talk about. User add is the default way of just creating a user account. There is absolutely no reason to use it unless you really, really want to. It does the bare basic. It will set up a line in etc password file that has the username, the default group, the shell that you're using, and home directory, and groups they belong to, which will just be the default ones, whatever you set up as a default. It'll then create the home directory, and that's about it. There is no reason you can't do all of this manually, and if you can do it manually, that means you can write your own script to do it. And if you're in a production environment, I would strongly recommend that you create your own script for creating users, using whatever tools that you're using within that environment to manage users, such as LDAP or tying into Active Directory. And in that way, you can get it set up all the mail accounts and everything else, which the standard user add script won't do. All right, group add resides in user sbin, just for adding a new user group, and then user mod to change what groups people are in. Okay, so you can have a bit of play around with those in the labs too. Right, I mentioned that we have the ability to schedule jobs. This is very handy if you're running any sort of services, you want to check things are done, you want to run cleanup and cache files, you might want to restart services that have memory leaks automatically. So if you're running, I don't know, some service called a web service, and it does have a known memory leak, or you know that it's becomes unreliable after running for a long period of time, midnight every night, you just do a restart on it, and you can set that into the into cron. Cron is really, really simple. It's a daemon that runs in the background, which just means it's a background process itself. And it runs through things on a schedule. And it's nice because it's all in a text file. All right, so you can do a nice text edit on it, and that easy to read. You don't have to restart the service when you make changes to the text itself, and very, very straightforward to use. And I did change that somewhere. Yeah, where that's gone. I just had something in a sample one. Oh, that's all next. All right, so we'll jump to the next we have minutes, hours, days a month, weekday, and the command it does, and that's the one I wanted to jump to. So when we schedule jobs, we can have an entry in the cron tab file. Right? As I said, tab means table, cron, it's cron tab, table. We can have a few entries here to specify how it's set up. Normal shell, in this case being bash, it has a path we mail to and then who we mail to, and this is really, really bad. This breaks one of the rules. Here we've got the mail to, and from will send messages when things happen within scheduled job. And we've got a mail to root. Never set up your mail to root, all right? Because you don't want anything having access to that root account. You don't want to be looking at mail as a root user, because if there is a vulnerability within the mail system, which there very, very often is, it's a way of breaking into the root account. All right? You send a malicious email to the root at curtin.edu.au. They then open that mail, it's got malicious attachment on it, bang, you've got root access to that system. Right, so never have your mail go to root. This should mail to the sysadmins group, right, which is just another user account or user group. Okay, so if we want to run a calendar command at 6:30 every Monday, Wednesday and Friday, the concat entry would be simply just a line going 30 space 6, right, hour, minute, so that's 6:30 in the morning. What is it? Day of the month. So this is for the month, so it's every day of the month. And then 1, 3 and 5, which is the days. So it's going to run on Monday, Wednesday and Friday, Sunday being 0. And after that we have the script we want to run. And this is just any user-defined script or program. So you can have your own jobs you've created a script for, run on a regular basis without any real problem. Okay, and again, that's handy for making sure things are still running, to run cleanup jobs, etc. You can set your backups in there as long as you get the tapes and that sort of thing loaded up beforehand. There's another way of keeping processes alive as well, apart from having them restart or check via cron or PS. We can put them in the init tab, and this is the initialization table. Then you can have a look at that. It's changed at the moment, so I'm not sure you really want to spend too much time looking at this. But what the init tab files do, and they're actually split up into lots and lots of other files underneath. If you look at /etc init.d, and there's another way of describing files. Do you know what the .d means? If you have a file name that ends in .d, it means it's a directory. Okay, so anything with a .d is actually a directory. Right, so if you look at the init.d, there's a whole bunch of files in there which are the init tab's entries. So I just changed a little bit from there. But init tab is when the machine is starting up, it looks at the particular run level that you're going into, and run levels we do talk about a bit later on, and starts up the processes, as in the services or daemons that are running in the background for that particular run level. And just quickly, run levels are basically single user mode, multi-user mode with graphics X11 and networking. And if you set the run level to 0, it means actually halt the system. And I think run level 6 is restart the system. Yeah. And that's how you can do your shutdowns and stuff too. All right, so keeping processes alive, if you put them in the init.d, the system itself monitors what's meant to be running and will ensure that it stays running at all times. And I thought you might want to try a few of these. The last slide 47, just showing how cryptic you can make commands. So if you want to copy them in and try them out. I do like that first one. Okay, right, so looking very briefly, we're going over time again. We'll start on the next one, but we'll keep going here. Web services. Now, web stuff is truly, truly awful. I hate doing web pages. I detest HTML and CSS and all that stuff, just because I find it really, really boring. But running the services isn't. Running the service is actually quite a nice thing to be doing, and they're good services to run, and they can be very, very interesting. You can do lots of things with them if you can find a monkey to go and type up the HTML for you. Generally, there's three main platforms nowadays. Believe it or not, iOS, which is the Windows 1, or was the Windows 1, I don't think it's changed, is not the most popular. In production environments, it is extremely unpopular. Windows services for delivering web pages and well, no, not so much content, is not common. When you look at when you look at the I keep thinking Netflix, it's not Netcraft surveys. They're people who go off and look at all of the machines on the internet that are running things. A lot of the hosting servers, those that just have names on them, right, so if you mistype a name and it goes off to one of the domain name registers, those names that don't actually have any ownership or nobody owns, they're just hosted somewhere and sat somewhere, will quite often be sitting on Windows machines. But when they're actually servicing something, they are generally not. Now, with iOS, you can configure that through the control panel that supports everything in one, which is what causes some of the problems with it. It's used for the HTTP protocols, don't say that. It's used for Hypertext Transfer Protocol, it's used for FTP, SMTP, which is the mail transfer, and many, many other protocols. Which means if it's supporting all of this stuff within one environment, it means it's got lots of chances of having vulnerabilities. Right? The more things you put into one container, the more chances that container has a vulnerability somewhere. So that is a problem on its own. It's also a really, really big process to be running. So you need to have a pretty powerful machine to be running this properly, because it's trying to run all this other stuff that you may or may not be using anyway. Much nicer to actually separate things out. It's inherently insecure. Well, I shouldn't say inherently. It's been known to be very, very insecure, but you can lock it down if you go through the right procedures. Now, just to give you an idea of realistically what's out there, Apache, which is not Apache web server, it's Apache web server, is very, very common. So if we have a look at the blue line here, this is Apache, and they're running at generally about 60% of the active web servers. Okay, Microsoft sits down around about, where is it, 7.5% of the servers. But there's the NG-INX system which is picking up and gaining ground. Alright, so still a few around. But there are quite a few different web servers around. IBM has its own, Sun has its own, but they aren't that common. They used to have one, but not anymore. Alright, there's a few of them there, so we can see that NG-INX is the one that's picking up, 20% market share, and Google Web Service is slightly different, but they're in there too. Okay, current version is version 2. Everything is configured in httpd.conf. Okay, nice little standard thing again. HTTP, that is the protocol, that is what we're trying to deal with. The D means it's a daemon running in the background, right? It's not a foreground type service, you run this as a background service. And the .conf means it's a configuration file. So the name gives you lots of information. Alright, so you should configure that. Installing it, easy, right? Generally, you'll just go through the normal package install for Apache. There it is, all up and running. You'll go to http:// my IP address, and it will give you a page. It worked. Right? So it'll say you're serving web pages already. But that is not configuring it. There is a lot to actually setting it up so it's useful and secure. So don't just illustrate installing and just leave it for people to dump stuff up, because it's not going to work very well. And even though it is open source, and open source is always good, it doesn't necessarily mean it's secure. And particularly with all the plugins that are available for it. Right, so configuration is probably a course all on its own. FTP, it's another service that we would normally not set up. FTP is really, really bad. File transfer protocol, it's how we used to shuffle large files around in the good old days, rather than having drive mappings or cloud-based storage. If you have things that you're going to be storing locally and you want to share with other users, you want some shared drive, correct? And you might want to be able to share it over the internet to people who are remotely located or people who are traveling without using the cloud. Reasons not to use the cloud are mixed and many, and we've got things on clouds coming up later on. But basically, my biggest issue with cloud-based systems is you don't know where it's stored. All right? So if you don't know where your data is stored, who owns it? Well, that depends on the laws of the country where it's stored, which I don't know where that is. Okay, if you're a corporation and you store your seriously important legal files on a server that happens to be in Uzbekistan, right? It goes under Uzbekistani law. What are their laws? I haven't got a clue, right? Is what you're doing legal there? Are you able to get that material back again if something happens over there? All right, so you're no longer tied to your local laws in whichever country you actually happen to be in. You are subject to some foreign powers law because that's where it physically resides. So that's the thing I've got against cloud-based storage. When it's my own photos and Word documents and other things, I don't care because I don't care. It's not important. But if it's corporate information, that would be very important. So be aware of that when you're doing cloud stuff. So one of the ways you can actually store files and material to share amongst your own people when it is sensitive is on your own servers, and one way of doing that is FTP, which is a really, really, really bad way of doing things. FTP is insecure. It can be easily hacked. WooFTP, which is Washington University FTP, was a classic for that, and it was so easy to hijack. Generally, they had a directory under FTP that was a /bin directory, and when you wanted to execute commands, whatever they happen to be, like ls to list the contents of the FTP directory structure, you would have the ls command in the bin file under the FTP, and it would be just ls. But that meant any user could go and put any command they want in there, and if they got FTP access, they could execute those commands. So you could put in malware there to compromise the system and just do an anonymous login to the FTP and execute that and gain whatever privilege you like. Right? So big hole in the system. By blocking anonymous login didn't solve the problem because it's a non-secure, non-encrypted channel. So if you were just sniffing the line, you could actually capture the username and password and then log in yourself. Just so many holes, it's not even worth contemplating FTP. There is SFTP, Secure FTP, which does use encryption, but there are better ways of doing things than FTP nowadays. But it can be a handy emergency system to run. Under Windows runs a subservice of IIS. Under Linux, it's an independent system, and you can set up using whatever FTP service you like. But as I said, not a very good idea. All right, better way to do things is share things via file systems, but this doesn't necessarily mean they'll be visible outside your local network. Some of these file sharing systems don't work outside the local area network, so they're a layer 2 type system, but there's lots of them around. One of the best ones to learn how to use is Samba, that deals with SMB. That is a Windows protocol, server message block, and this is how Windows handles its file shares and sharing of drives, etc. It was reverse engineered by a couple of blokes in Queensland, and they developed Samba to run on Linux machines, which replicates the things that happen within the SMB protocol of Windows. And that includes the replication of domains, so they can interface with Active Directory through the domain system. It can mount and share drives and locations, and you can have user authentication as well through SMB shares. So very, very powerful, but very simple system to set up. Okay, with Windows, it's all done through the MMC or through the file manager, and you can also do it on the command line, which is that next slide. Okay, Linux becomes a little bit more complex because there are so many different options within the file systems that you can use. Some of the ones we should look at here is NFS, Network File System. Makes sense, doesn't it? They rely on a multitude of other protocols like the RPC, remote procedural calls. They're also used in Windows as well. So these are a protocol that allows you to send commands and attach and mount other remote drives. We can create a share through the etc exports. So editing and have a look at that file. If you look at the etc exports, it has the shares on other machines within your local area network that you can mount from your machine. And normally you would not do this automatically because you don't know which machine you're going to be logging into because you share. So you would have to go through that mount command system and know what file system you're mounting, okay, and have a mount point set up as we saw previously. But we can have this so that when you log in, you can pass that share out through the exports. Okay, there's some options for it. You can read through those, have a try. It's no point just reading that out. One of the couple of things to be aware of when you're creating these shares, each implementation has a different level of protection that applies to the shares when you create it. Right, so when we create a share of a parent directory, let's call it parent, right, what happens to the contents underneath? Is it visible to everybody? Is it not visible? How do you make that exported file share visible to somebody else? Under Novell NetWare, which was a really nice secure system which is now defunct, you had to explicitly give permission for every single view. So when you wanted to share a directory, you would say, yes, this group of users can see this directory. Now, the files. These group of users can actually see these files. Windows, on the other hand, does it differently. It says, right, you've shared that, which means you want everyone to see it so everyone can see it. And then you have to go through and lock everything down. So things that you don't want people to see, you then have to remove the rights of users to see those particular files and directories. Easy under Windows, which is why they did it, right? Because once you share something, it's shared and everything's available to everyone. But you've then got to remember and make sure that you lock everything down and remove access to things that you don't want people to access, which means you may forget something. The NetWare Linux Unix way of doing things is you lock everything down and then release things as people require them, which is a much more secure way of doing things, but it can be a right pain in the neck because you have to go through and manually do all of the file permissions to allow people to see. So basically that's what we're talking about now. Under Linux as well, you can actually have things to be able to be seen, but not able to do anything with them. So if you, one of the interesting things you can do, if you set your file permissions on a file to be no read, no write, but allow them execute, what happens? So you can't see the file, you can't read it, you can't write to it, but you can execute it. Try it out, because it's implementation dependent. Okay. Yes, and then we have the hide and no hide options within the etc system. Right, and there's some examples of it. If we look inside the config file, we're exporting these particular shares. First one is user games, or USR games, and we want box 1 to have read-only, computer 2 to have read-only, and we can also specify IP address and IP address ranges for the access of that particular share. We have home, which we're allowing the full domain name for this particular machine, box2.external.net. We're giving it read, write, and no root squash, which means it can actually log in and have root access. Okay, and they're all explained there anyway. We can export file systems as well, which makes them available to other systems. Through NFS, we can have a look at the NFS stats, and that will give us information on network mount drives. All right. So that's what I was saying about users. One thing you want to be aware of with users, as I said, when we create that new user, the first thing that goes into the etc password file is the user ID. That user ID is unique to that user, obviously, and it's how all of its child processes and the system interacts with that user. Now, when you set a user ID, that user ID becomes a member of multiple groups. The user ID becomes a member of the groups, not the username. Which means if I only log in on this machine, I get one user ID, which will then give me a set of groups that I'm entitled to have access to. But if I log in on that machine, I might get a completely different user ID, which means it can't map the group IDs to that user because it's a different user ID. So we have the ability with the file system to actually set the user ID from a central NIS type system. So NIS is Yellow Pages, that's why you get YP bind and things with it. It used to be called Yellow Pages until Yellow Pages got upset and said you can't use that name. But it's the Network Information System, I think, stands for. But that's a way of having a centralized authentication. So you have an NIS server, which you, from any machine, try to log into. It queries the NIS server, and it then gives you all the mount positions, your user ID, your group IDs, all the same, on the machine, mounts your home drive from whatever machine it happens to be on, physically on, and allows you to log in and get your own environment from any machine you actually log into. but it's not very scalable. But it is a really good system to learn because it's fiddly and it shows you everything that can possibly go wrong, because it does. So no doubt we've got a lab on NIS in there as well. Okay, so there's a little bit more on Samba. Samba is a file sharing authentication system. Really nice to set up in small networks. So if you want to set something up at home to share drives amongst multiple machines, you can do it with Samba. This thing does name resolution for basically the authentication, and also for NetBIOS and other local area networking things. Allows you to browse window drives, etc. So you can mount up. You can use Samba to I'll get this right. You can have Samba running on your Linux machine and then use your Windows machine to browse to the file structure on the Linux machine. Right, so it allows that interface between Windows and Linux. Okay, so it uses server message block, and also known as KIFs. It's a client-server model, so you need to have your Samba server and then your Samba client. Samba client is just basically what comes with Windows if you're using a Windows machine. Okay, we'll make a start on the next one because it's still very much related. 6. Okay, and I'll really just go through the soft skill type bit of it before we run out of time. Okay, so we're looking at user management. And with host management, we've got a couple of things we need to decide, particularly when we're initially setting up the end user's machines. All operating systems come with a default install. Yeah? Should you ever use a default install in a commercial environment? No, because you don't know what it's going to do. It's going to be a one-size-fits-all. It's not going to suit your requirements, your security, your normal usage, your user profile, anything. It's a compromise of all things. So whenever you get the option, do you want to do an advanced install? If it's a work environment, a real environment that you are in control of, you never do the default install, you do a custom install. And that's from server or desktop. If you're running a Mac, you don't get a choice. There you go. Okay, so you should always create your own setup. Now, one of the really nice things about Linux and Windows is you can create, I keep saying that? Unattended installs. I always call every Windows installation an unintended install. Yeah, anyway. Which means that you can actually set these up and you boot the machine up and it goes and installs the software as per your configuration yourself. And Sindel, if you ever want to do a real Windows install from scratch, this is the only way you can do it. Right? You set up the unattended install files, you do those separately, you move them onto your install media, and it will do the basic install to the point where you can start getting voice feedback. But for the rest of us, we use it when we've got bulk installs to do. So we can just install from scratch, not have to be there, and it'll run through the configuration as we want it for our installation, not as the vendor wants it. The other things you've got to look at is, are you going to make all the machines identical? Why would you make all machines identical?
Maybe you've got identical machines set up.
Yeah, and it's nice and easy to maintain. Right? Every machine's the same. You know what's on every machine. You know how many licenses you need. You know when you've got to patch things, you go and patch all machines. Very easy to have, right? But it doesn't necessarily give the best option to your users. And as I said right back at the beginning, your job as a system administrator is not to build your empire, even though that's a hell of a lot of fun. It is not to make users' life hell, even though that's even more fun. It is to provide a service to those users so they can do their job. By putting a one-size-fits-all and applying that to everybody, nobody's going to be happy. Too bad in some situations. And people may not be able to do their job as well as they could, but your job will be easier, and that's the wrong way to do things. Right? It may be more work for you, but sometimes you do need to do different installs and give people different environments. Right? So these are decisions you actually make when you're installing, and this is something that should also be on your assignment. Are you going to have all of your machines to be Windows 10 standard install? You get this, like it or lump it, which would work great for a bunch of lawyers or in a retail environment or accountants, but certainly wouldn't work in a software development company. All right, so make sure that you think about that. Are you going to make the machines alike, and are they going to be different, and why? Remember, I'm always looking in that assignment for why. Why have you decided this? Can you convince me that your way is right? Okay. When we're looking at the overall management, and I don't want to go too much into this because it's changed a fair bit since 2 years ago. But vendors generally look at the individual hosts. They don't look at your overall network view and how you're trying to do things. So they're really saying, this is a machine, a person's going to have this machine, so we look after that machine for them. And probably the easiest way to think of this is your Windows machine, where do you save your files?
C drives.
Yeah, C drive. You're in a corporate environment. Where do users save their files? Their C drive because they're used to it, and that's the way Windows is designed. How do you back up 10,000 C drives? Not easily. All right, so Windows, Microsoft has decided the best way to save files for a user is to have it on their C drive, but from a real administration point of view, you want to block access to that C drive. Right? You want everything to be saved on your network drive so you can back it up easily. It's all in one place. You have an authentic, validated source of data. You know, people can't change things locally, change a price list, for example, and sell cheaper rate to their mates because it's all central server. It's all there. Everyone's got the same copy. Everyone's getting the same information. All right, but the systems like Windows, Mac is just as bad really, even though it's Unix underneath, are not designed for this corporate mindset unless you apply something else on top of it. All right, so that, again, is very important, looking at things like where they are stored. When you're doing your installation, we have a server room. And this is really, really critical because I've seen this so often. I did some contract work for a mortgage broker, multi-million-dollar mortgage broker, very, very famous. All of the directors went to jail. Yeah, great while it lasted. They paid really well. But there's about 20 or 30 people in this office, and they are dealing with personal finances, corporate finances, and arranging financing of businesses and individuals for money laundering or something they got caught for. But they had a central server that they asked me to come in and fix up and do make sure their backups were all there. I walked into the reception area, which was pretty low, and asked the lady behind the desk, "Where's your main server?" And she said, "Oh, it's over there underneath the coffee table in the reception area." Okay, really secure. Anyone could walk in, screen sitting, keyboard sitting there. Just walk in and start using it if you wanted to. Okay, so we really don't want to have that sort of thing happening. So we need a proper server room. And there's a few things we need with that. It needs to be separate. It needs to be able to be locked. It needs to be separate for fire containment, okay, because there's lots of electrical equipment in there. It can burst into flames. We don't want it spreading anywhere else. If there's a fire somewhere else, we don't want it spreading to our servers. We need proper air conditioning. We've got to look at the placement of the servers. We need to be able to get in and work around them. So if you haven't been in there, go and have a look. We've got a little bit of a server set up in there that you use in other units. In fact, you use it in this unit later on, just do a quick virtual machine transfer. But because there's a lot of cabling involved, you've got to be able to get around the cabling. You've got to be able to get decent airflow through it, and airflow is very, very important in big server installations. But what you don't want to do is set up your server rack around about here, because there's an air conditioner, right? And this actually happened to the engineering servers when we had them sitting over building 204. Brand new server, got it all set up. It was really big, powerful beastie, very, very expensive. They put it in the server room, which was nicely secure and had anti-static matting, so it was going to be looked after. Humidity was controlled. And they mounted it against the wall over there, directly underneath an air conditioner.
Oh.
Air conditioners cool things. When you cool air and there's a lot of moisture in it, what happens? Moisture comes out and it condenses and it just poured into the server and blew the server up the first weekend it was installed. Simple thing, by placing a server in the wrong place. So you've got to be very aware of everything you're doing within your server room, where things are placed, where the airflow is, because you can get hotspots in rooms, particularly when you start to get larger rooms with lots of equipment in them. Make sure that the airflow is there, make sure that you can get to them, ensure that there's no carpet or things that are going to cause static. Get your backup media the hell out of there as soon as you can. And also, you should replicate things on other premises where you can. And again, we'll cover more of that in the disaster recovery lecture. Other things you really need, uninterruptible power supply. Really, really important. Not just for getting enough power to maintain the machine running long enough so you can shut it down properly. And it's important to shut things down properly so that you don't lose things that are cached or things that haven't been permanently written to disk. But taking Western Australia's absolutely awful power, turning it into DC through a battery system, so you do a AC to DC conversion, store it in a battery, then feed off the battery to actually run your AC, and in that way you're taking dirty, noisy, unclean power, storing the energy, then taking that stored energy off in a nice, clean, no spikes, no brownouts, no harmonics or noise into your server system. Because one of the main problems with servers is the power supplies blow up. They blow up for a variety of reasons. And probably the most common one is people don't clean the dust out, they get hot. When things get hot, electronics stop working. And the other one is power is noisy. It goes anything between 180 volts to 400 or 500 volts in spikes. Or the worst thing that can happen is the power falls to 100 or so volts for a extended period of time. That causes a massive current draw, which actually burns things out. So a brownout where the voltage drops is actually worse than a spike. So by running through an uninterruptible power supply, you take unknown dirty power and you turn it through AC to DC, sorry, AC through DC to AC again, conversion into nice clean power which will protect your system. And because it's got that battery backup, you can set it so that the system's shut down cleanly. And generally, on a decent UPS system, you'll have it set up so that if the power does drop out, you start an automatic shutdown of the system. So the UPS will actually talk to the servers and shut them down if there's a problem. Always avoid single points of failure, right? So never have one server have two, even if the second one is pretty iffy and won't cope very well with loads. Your hard disk should be RAID so that if one fails, you can keep running or recover the data without having to do a full restore. Because as I said, tapes are read from beginning to end, and that can take a very long time. So restoring from a failed drive system can actually be very time-consuming and take quite a bit of time. And if that's your business, you're going to be in a lot of trouble, loss of income, etc. What else is here? So we're all familiar with RAID. Had a look at RAID 1 through 5, and make sure you read up on RAID just for your own interest. It's not part of this unit. You should be. Understand what the different RAID levels are and how they work, particularly going from RAID 5, looking at RAID 5, because that's really the one that's good and reliable. Okay, we need to protect it from floods, fire, that sort of thing, depending very much on the local environment. So if you're a system administrator in Florida, you'd want to make sure you had it well protected against floods at the moment. If you're in the northwest of Western Australia, you also want to make sure it's protected against floods and white ants. White ants will eat plastic, by the way, termites. And they eat through the insulation of the power cables and all kinds of horrible things. So yes, you make sure it's protected, both from flood and fire. And this one I've taken directly from a textbook. I absolutely love it. I think it's great. Important computing equipment can be placed in a Faraday cage. These are the cages that take away electromagnetic radiation, shielded from interference. And this is a bit I like. Where is it there? Oh yeah. Or to protect it from electromagnetic pulses. For example, from nuclear explosions or other weaponry. If there's a nuclear explosion, I'm not going to be terribly worried about my servers. I think I'm going to have other things to worry about. So anyway, I just thought that was great. Put it in a Faraday cage in case a nuclear bomb was dropped on it. Highly unlikely. Anyway, I left that one in because I just thought it was fun. Okay. A really important thing here is the cabling for the servers and the environment. Again, go in and have a look. I don't have a key, but Jonas has got a key. He's still mine. And just have a look at the amount of cabling from a very, very small server system in there. It's only 6 odd servers and, I don't know, 18 routers and switches. So it's not big, right? But there is a massive cable there. When you start to get to a real server farm, the cables take up more room than the servers. You must make sure you label the damn things. You know what's at both ends, right? So you've got to label at both ends. Labeling on one end is not going to help you a lot. So you've got to make sure things are labelled at both ends. Keep cables very tidy. And there's reasons for that. It's so you can follow them when there's a fault. It's not because it looks pretty and it's nice. is because if things are a tangled mess, you will never find where the fault is. And it could be something as simple as a cable popped out. But if you can't find it and follow it, you're never going to fix it. All right, so very important. Humans should not be able to unintentionally touch equipment. And this is a really good point, and I can give you a good example of that too. I worked on Prime Super Minis mainframes, again, back in the 80s. They were nice machine size of a fridge, took about that tall, and the power button was right here on the front panel, right that height. So you could actually, on a mainframe computer, lean on the power button and turn the thing off. And I did it at the R&I Bank, which is now Bank West, on the machine that handled all of their, what were teller machines at the time. So this is the machine that was reading passbooks, right, and printing the transactions on the passbooks. And I'm standing there with my arm on the power button going, I've made a boo-boo. And I had to wait for half an hour while somebody came in and physically shut the machine down, notified all the branches they had to log out, wait for a little while, then they can log back in and continue operating as a bank before I could actually take my arm off. So never have machines where they can be touched. Lock them in cages. Those in there don't have the doors on because we're too lazy to put them back on. But normally your servers will be in a cage, and it is actually like a Faraday cage, with a lock. The key will be somewhere. It doesn't necessarily have to be securely put away, the key, right? If you just leave it hanging on the front, that's fine, because it means you'll walk in, you'll unlock the cage, you'll hang the key back up, do the work you have to, close it, lock it, put the key there. It means you can't accidentally reach in, touch anything, break anything, etc. All right, so static electricity is also a problem, humidity is also a problem. Too high humidity, these things rust. Inside they are copper, they corrode. All right, so you've got to keep that humidity down. Keep the humidity too low, what happens? Low humidity environment. No, but you do get static electricity. Right, and a static build-up will kill electronics really quickly. Okay. We've talked about this before, but we've got to think about customising the installation for the workstations, the end users' machines. There's lots of different ways of doing this. Cloud-based systems is really good. One thing we're going to play with, and you guys might want to play with this when you get to your projects, is the virtual desktop environment where we're using large servers to deliver the workstation back down to a web browser on the client machine. And it means that everything is nice and centrally controlled. We have one image that sits over in that server room. We do updates in that to one image, and we can just send it out to anyone wherever they happen to be. And that's a really nice system in some cases, but it requires very high network bandwidth, so unless you're on the fibre to the node NBN, forget it. Which I have, which I'm pleased to tell everyone. I like stirring people up. All right, so that's one way of thinking the story. Heading. We had thin clients previously, and that's basically, again, what we're coming back to. So when we're delivering these virtual machines to end users, we're going back to the old dumb terminal, right? No brains at the end, everything's thought of and handled back in the central system, the server end, the cloud, whatever you want to call it. And we're delivering it back down to the end user through something that's not very clever like a web browser. We have diskless workstations, X-terminals, which failed, but they may actually come back. When you're setting things up, one of the important things to do is to look at the partitioning of the disk drive, particularly on the server side, because this will assist in your backup and also the efficiency of the system. Good practice, separate out the operating system. So you have a separate partition. Think your A, B, C, D, E drives in Windows, which is never enough letters, by the way. We had constant fights at Curtin over who can use which letter because there isn't enough to go around. Doesn't happen under Linux, Unix, and Mac because they're all named. All right, so separate out the operating system. How often do you change your operating system? Very, very rarely. Yeah. You'll have an update every now and again, every month or two. But the operating system's fairly static. Right? So you can sit there and sit your operating system on a separate partition on the hard drive. We have shared areas for the users, then we have log areas which we put on another position. This helps us with our backup because we can separate out the things that change rapidly and often, right? And that's the drive that we back up. So logically that makes sense. But it also makes a big difference on efficiency of the system. If you've got multiple hard drives, not just partitions, and you have your operating system on one hard drive and your user's on another hard drive, you can be writing while seeking out on that hard drive and writing or reading on that one as it's, the other one's seeking. So you can be doing multiple operations from one interface card within the server to each of the drives. Right, so you can actually improve the efficiency quite dramatically. One of the major bottlenecks on all server systems is the I/O. How do we get data in and out of them quickly? Right? And the buses and the I/O is actually a major limitation on the maximum speed we can get on these things. If you compare the speed of accessing information from a drive or well, from the hard drive on these machines, right, which has the old spinning disk drive, compared to, I think they've got spinning disk drive, haven't they?
Probably.
I think they have. To the SSD stuff that's on most modern laptops, there is a huge difference in the performance, right, which shows that the I/O is our problem. Rotating disk drives, very, very slow to access. SSD, really, really quick to access. Only problem is you've got a limited number of read and writes on a SSD, whereas you don't on a spinning disk drive, but then bearing drive. Okay, so it makes a lot of sense to logically separate out the partitions into things that are going to be read-only. Right, so you can set your operating system to be read-only. Right, you've set up a separate partition for the virtual memory, if you know what virtual memory is, I hope. We have a separate area for Scratch, virtual memory and log files and that sort of thing. Right, so that's the one that's going to be thrashed all the time. It'll be a drive that wears out really quickly. And also it's separated off and you don't have to worry about backing it up. Okay. We also want to do the same thing with our networking where we do our shares. For backing up, that was the information I was talking about there. We can use different partition names, etc.